Scale factor. In similar shapes, the scale factor is the number that the sides on a shape have been multiplied by to scale it up, enlargement, or scale it down, reduction. So if A was our original shape and it had been enlarged to this copy, A to B would be an enlargement, then obviously for that we have multiplied by 2, so the scale factor is 2. If B was our original and it had been scaled down to A, being the copy, then that would be a reduction. But we don't say we divide by 2. We always want a scale factor to be a multiplication, and so to get half of it, that would be multiplying by a half. So both of these are the scale factors in this scenario. We are multiplying by a number greater than 1 for an enlargement, and we're multiplying by a number less than 1, between 0 and 1, for a reduction. I'll show you how to calculate this correctly. Our scale factor is found by dividing a length on our copy by a matching length on the original. So whether it's a copy or an original is dependent on the situation. So if you are enlarging, then the bigger one is the copy. If it's a reduction, then the small one is the copy. And if they didn't tell you if it's an enlargement or a reduction, which they won't have in the next question that I've got for you, then the one with X, or the unknown, is the copy. So in this question here, find the scale factor and use it to find the value of X in these similar shapes. So we do have to know that the shapes are similar to use the scale factor to find an unknown. And there's again 2 types of questions here. We might just get asked to find a scale factor. We might get asked to use it to find an unknown value. So they haven't said if this was an enlargement or a reduction, but the one with X is the copy. So our scale factor is copy over original. We've got a matching pair of sides, 10 centimetres and 24 centimetres. So it's the length on the copy divided by the matching length on the original. And you grab your calculator and do 10 divided by 24. And that's an inconvenient number. You could just leave it as 5 over 12, to be honest. That's probably easier. If you wanted to round it, 0.416 repeater, leaving it as a fraction is a good idea. Now, just incidentally, the letter that we use to represent a scale factor is K. K equals my scale factor, so I can say K is 5 over 12. Once you've got your scale factor, that is the number that 24 was multiplied by to get 10. So that means that to find X, it is the matching side to X, 18, multiplied by the scale factor of 5 over 12. I'm sorry, I should find a better calculator. So I have 18 multiplied by 5 over 12 and x is 7.5, and we're in centimetres. So that is finding a scale factor and then multiplying a matching side by the scale factor to find an unknown. The other thing that we can use the scale factor for is finding an area scale factor. Very quickly, because you might get asked for the scale factor of the areas or the ratio of the areas, let's just find the area of each of these two shapes. Area equals base times height over 2. That's 18 times 24 divided by 2. (216 centimetres squared). This one here, we know that's 7.5. Area is base times height over 2. 7.5 times 10 over 2. So that is half of 75, which is 37.5 centimetres squared. Now these are in a ratio, but the ratio of areas is not the same as the ratio of lengths. Let's just pick a really nice easy one. My example up here. Here the ratio of length was 2. If I find the area, very quickly, the area here is 6 and the area here is 24. You can see that that's definitely not doubled. So the ratio of lengths is 2. The ratio of areas is 6 to 24, which is 4. If I simplify that down, the area is 4 times the area in the large one. There is a pattern. This one here, you can see that it's definitely not the same sort of ratio. This is much, much larger than you'd expect comparing that. So the secret is the length scale factor is K. The area scale factor is K squared. That means if you've got the length scale factor, you square it to find the relationship between the areas. Flipping back here, the length scale factor here was 2. K equals 2. K squared is 2 squared, which is 4. Sorry about this bit here, I got messy. And the areas, 6 times 4 is 24. So the relationship between the areas is gained by K squared. If we checked on this one, can I get the area? If K is 5 over 12, then K squared, the area relationship, should be 5 over 12 squared. You'll often get asked to find the scale factor of area. So if you've got the length scale factor, just square it. And a little calculator's easier. 5 over 12. Oh, sorry, let's pop that in brackets to square it. 5 over 12. Close your bracket. Sorry about that. And square it. 25 over 144, we could have done that ourselves. Now what that's saying is that we multiplied 18 by the scale factor, k, to get x. If I do the area of this big one times the scale factor, the reduction factor here, I should get the area of the little one. So I've got that ratio, 25 over 144. I'm going to multiply that by the area of the big one, and we get 37.5, the area of the small one. So the big thing to take away is that your scale factor is the length on the copy divided by the matching length on the original. That is your length scale factor, k. And to get the area scale factor, you find k squared.